Hello, welcome to this presentation on confidence interval. In this presentation, we are going to go over confidence interval for mean when population standard deviation is known. But before that, we are going to explore some of the key terms that we must know uh, to explore the confidence interval. Okay, here we have some basic terms. The first one is a point estimate. A point estimate is a specific numerical value that estimates certain parameter of the population. The best point estimate of the population is the mean. So, meaning of this is if I want to determine or if I want to predict the population mean, I need a point estimate which is called the mean of the sample in this case. So if the mean of the sample is somewhere here, suppose that is the mean of the sample x bar, then if I want to predict the population mean, and if I want to say that the population mean is within this range, then this middle value which I select for the prediction, that is called the point estimate. So normally point estimate is the mean for the confidence interval for mean. Now when we say interval estimate of parameter is an interval of range. Like in this above picture, it's the range of values, all these values. Okay, we can say that the population mean lies within this range. That is the interval estimate of the parameter, is the range of value to estimate the parameter. This estimate may or may not contain the value of the parameter estimated, but we say that that is the interval of estimate. Few more terms. Next we say confidence level. So what we have seen in previous slide is if I want to estimate the population parameter mu, that is the mean, then what I do is I will have the central value for the interval called the point estimate, and this is the interval of estimate from here to here. This is the interval of estimate. I can say that the population mean mu lies in this range. Okay, but I have to say this with certain confidence level. So the confidence level are like 95% confident, okay, or 90% confident, or 99% confident. These are called the confidence level. So when I say confidence level, the confidence level of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter. If I am 95% confident that the population mean lies in this interval, that is the probability that mean lies between this lower value and that upper value is 0.95. That is the meaning. So confidence interval is a specific interval estimate of a parameter determined using the data obtained from sample using a specific confidence level. So in order to obtain the confidence interval, we must have some sort of information about the sample, and we must also have the confidence level at which we are estimating the parameter. As I mentioned before, there are three commonly used confidence interval. They are 90%, 95%, and 99%. Okay, let's go to the confidence interval for mean. So the first one is confidence interval for mean when the population standard deviation is known. Sigma is the population standard deviation. This is population standard deviation. So how we can find the confidence interval when population standard deviation is known? The idea is simple. What we have to do is, as mentioned in the previous slides, we must have the point estimate in the middle, which is x bar or the sample mean, then we must have something less than that and something more than that so that we can get this interval, which is called the confidence interval. Something which is less than the point estimate and something which is more than the point estimate, this value that we are adding on this side and subtracting on this side, this is called the margin of error. This is called the margin of error. So if I want to find the confidence interval, so the lower end of the confidence interval will be point estimate minus margin of error. And if I want to find the upper bound, it will be point estimate plus margin of error. So the confidence interval for the estimation of population mean is the point estimate plus or minus margin of error. Or you can say x minus mean is the lower end, x bar, that is the sample mean, plus margin of error for the upper bound, and the sample mean minus margin of error for the lower bound. Okay, so between these two values, this value and this value, between these two values, you have the population parameter mean. And how do we find the margin of error? Formula to find margin of error is this. Margin of error is equal to z sub c multiplied to population standard deviation divided by square root of n. This z sub c is same as z sub alpha over 2. What is that? Let's look at this. Suppose if I have a normal curve like this, okay, if the population is normally distributed because your sigma is known, and if the population is normally distributed, and if I'm looking for, let's say, 90% confidence interval, so this interval is 90%, 90% confidence interval, then my confidence level C is 0.9. Okay, and out of 100%, the 10% is remaining here and here, which is equally divided into two parts. So total is 100%. We already have a 90% here. So 10% is remaining, and that 10% is divided into two parts. Okay, 10% is divided into two parts, which is 5%. 5% is here, 5% is here. So this z value here, it is called the z critical. Okay, this is the z critical, zc. It will be negative over here and positive over here, zc. Also, you can see that the same point divides this interval to these two areas, which is half of 10%, half of 1 minus c. So 1 minus c we call alpha, significance level. So this area is alpha over 2 and this area is alpha over 2. We divide alpha into two parts, alpha over 2. That's why zc can also be written as z alpha over 2. Okay. Now, once we know the confidence interval, we can easily tell the probability that the parameter lies in the given interval with certain confidence level. Sometimes, in order to get certain confidence interval with certain confidence level, we don't know the size of the population. If we want a size of the sample, so in that case, if we want to find the sample size, the minimum sample size for interval estimate of the population mean is given by this formula here. We can obtain this formula from this equation here. You have margin of error equal to z sub c, or you can write z alpha over 2 sigma, or the population standard divided by population standard deviation divided by the square root of the sample size. If we simplify this equation, we'll get this. This will give you the size of the sample for an interval estimate of the population mean. And when you find the result using this value, you may get a decimal value, but all you have to do is you have to round it up all the time. If you get 12.2, it will be 13. If you get 12.7, it's 13. So always round it to a whole number greater than the value which you will obtain by using calculator. Okay, so based on this, let's take two examples for this video. First example, let's see what is given. The age of smokers first starts from previous study is normally distributed with the population standard deviation of 1.8 years. That is your population standard deviation sigma. A survey of smokers of this generation was done to estimate the mean age. So we want to estimate the mean age of the population. So for this, what is done is the sample of 35 smokers, n equal to 35, is taken, and their mean was 14.7 years. That is the mean of the sample. And the 95% confidence interval is given. So that your C is 0.95. So we have to find the confidence interval. What we know is the confidence interval will be, if you remember from the previous slide, it will be the point estimate plus or minus the margin of error. You already have the point estimate, which is 14.7. So this is same as 14.7 plus or minus margin of error. So all we need to do is find the margin of error. So let's find that. Here, margin of error, if you remember the formula, that is equal to Z sub C population standard deviation divided by square root of n. Now, in order to find the Z critical, we are going to take our normally distributed population. You can see when the population is normally distributed, what we know is whatever sample you take from there, from central limit theorem, you know that the sample are also normally distributed. So if I want to graph the probability distribution for sample means, it will also be normally distributed like this. Now I want 95% confidence. So this area in the middle should be 0.95. That should be 0.95. And I need this Z critical. I just need the positive value. So what we can do is we can use the inverse normal function from our calculator and find that value. Let me rewrite this a little bit. So margin of error is equal to, okay, Z critical from calculator. So what we do is, in order to find Z critical, we go to second, then vars, number 3, inverse normal. Our area is 0.95, mean 0, standard deviation 1. We are considering standard normal distribution. Our area is at the center, so we select that, and we are going to paste all these in the main screen and hit enter. So the values are negative and positive, but I want just the positive value. Let me round this value to 4 decimal places and write it here. So it will be 1. Okay. In order to round anything in your calculator, the simple thing you can do is you can go to mode, come to this third line, and select whatever number of decimal place you want. Suppose I want 4. Hit enter. Then let me retype that. And you can see it is 1.96. So Z critical is 1.96. Standard deviation sigma 1.8 divided by square root of n. Our sample size is 35, so n is equal to 35. So that is equal to, let me type that in calculator. So we have 1.96 multiplied to 1.8 divided by the square root of 35, which is equal to 0.5963. 0.5963. That is the margin of error. So confidence interval is this one, which is 14.7 plus or minus margin of error, which is 0.5963. So we can write like this. If you add the values there, 14.7, let me add here, 14.7 plus 0.5963, the upper value will be 15.2963. If I subtract 14.7 minus 0.5963, the lower value will be 14.1037. Okay, so we can write this as, you can write the confidence interval like this. Confidence interval is from 14.1037, that's the lower value, up to the upper value was 15.2963. That is the confidence interval for population mean. Population mean, which is mu. So we are asked to construct the 95% confidence interval. So we can say that with so the probability that the true mean of the population lies between these two values is 95%. Or you can say with 95% confidence, we can say that the population mean lies between 14.1037 and 15.2963. Sometimes we can also write this interval like this. 14.1037 is less than population mean, which is also less than 15.2963. So meaning of this one is your population mean is between 14.1037 and 15.2963. And the interpretation one more time is the probability that the population mean lies between 14.1037 and 15.2963 is 95%. That is the probability. So you can say that with 95% confidence, the mean lies between those two values. So there are several different ways of interpreting the same thing. Okay, so we constructed 95% confidence interval for population mean when population standard deviation was given and we already knew that the population was normally distributed. So that was the first formula that we have seen here. Now let's know how to use the second formula, that is determining the sample size for an interval estimate of population mean. So let's solve this example. You are interested in estimating the mean age of citizen living in your community. In order to do this, you plan on constructing a confidence interval. However, you are not sure how many citizens should be included in the sample. So you can clearly see you have no idea on how many citizens should be included in the sample. So we don't know what is n. N equal to how much we don't know. If you want your sample estimate to be within 4 years of actual mean, that is, mean is the estimated mean plus 4 and estimated mean minus 4, meaning of that is this 4 here is margin of error. Okay, so here margin of error is equal to 4. That is margin of error. with 96% confidence. So C is equal to, confidence level is 96%, 0.96. So we have to find how many citizens should be included. So what is your N, okay, in your sample? Assume that the standard deviation of age of all citizens in this community is 25. So you can clearly see it is the standard deviation of all citizens, that is the population standard deviation, which is equal to 25 years. Now I have the confidence label C, but we need to find what is Z value for that confidence level. So for 96% confidence level, Z sub C is equal to, so we can find this using our calculator again. So what you do is you go to second, vars, number 3. You already know this is the area in the middle, which is 0.96, 96%. It should be the area at the center. So paste this, hit enter. We're just taking the positive value, which is 2.0537. 2.0537. Okay, we have everything now. Let's use the formula for N. What you know is N is equal to Z sub C times sigma divided by N quantity squared. Whatever value you'll get, you'll round it to a bigger number, a whole number more than that. So Z sub C 2.0537 times sigma population standard deviation 25 divided by not N, I wrote something wrong here, margin of error, and margin of error was 4 squared. Now let's find this and round it to a whole number, round it up to a whole number, a bigger whole number. Okay, parenthesis begin, we have 2.0537 times 25 divided by 4, parenthesis close, square, and hit enter. We get 164.7533, but we are rounding up, so that is 165. So sample size must be 165. So sample size must be 165. Okay, so that is how we can find the sample size when we know the confidence level of the interval we are constructing. So we solved two problems based on what we have seen here. We have seen the formula for the confidence interval when the population standard deviation was given. And then in the second formula, it was the formula to calculate the sample size. So in first example, you can see we learned how to calculate the confidence interval when confidence level was given. Here it was 95%. And in the second one, when we already know the confidence level, we know the margin of error and population standard deviation, we calculate the sample size. And one thing to note here, after you simplify everything, what you have to do is you have to look at the value. If it is a decimal value, you have to round it up. So here 165, that was the sample size. Okay, that is the end of this short video. I hope it was useful. Thank you for watching.